We are back. Been doing a whole lot of little fine-tuning and stuff over the past couple weeks. Some of it's been streamed, some hasn't. But we're getting closer. Much closer. Yeah. So I guess what I'm gonna try to do today, depending on time restrictions, I need to, let me go ahead and start hiding some layers here. I need to start going through and adding the offset spade bolts for all of my rails, and then just kind of locating where the holes will be for those to mount in the flat patterns for the sheet metal. Ooh. That I need the subway assembly right now, which is don't need posts or plastics. So this should kind of give me a good canvas to work with. Oh hey, what's up, Lurker? What's up, Matt? I'm going to build this from scratch, yes. So this all started out as just really an empty file. I did a lot of work, and I mean a lot of work. You can see I'm on version 518. But adding all the stuff in here to get this to a point where I can actually cut out a whitewood. So this all started with Visual Pinball, which is a software you can use to, play pre-made tables, but you can also use it to make your own. And so I used that software to mock up a layout that I liked, that flowed nice and hopefully had some fun shots. We'll see how that all translates in the real world, but from what I understand, it all kind of translates over pretty well. But my goal for today is to start off. You can see back here, I've got these spade bolts in here that hold the guide rails in place, and I just want to get those put in for the rest of the guide rails, so that way I can figure out where these holes need to be. And then after that, you see I have this, this nice list that I call the Road to Whitewood. And the one thing left on it is after I do the spade bolts, is the pilot holes for the wood screws on the back side of the playfield. And then from there, and hopefully on this stream, I'll start to transition to creating the toolpath so I can cut this out on my CNC. And we'll see where time leads us today. But if I do what I want to accomplish this early afternoon here, I would like to see if I can set up a stream out in the barn for cutting the CNC, or cutting the whitewood on the CNC. I think that would be really cool. But I don't know how long it's going to take me to do everything I want to do. I've really underestimated time on this whole project from the beginning. I mean, I've been working on this for a solid year-ish now to get to this point. And I thought that I was going to be done in a year, because I'm stupid and new. Look, it's kind of the morning. I'm going to start off slow here, okay? I'm having my coffee, and just kind of, you know, working up the ambition to get more stuff done. Alright, so I have this whole library of different assets. So I've got coil mechs, a lot of stuff you can find online, the files already, but I've also had to make a lot of different things. Fasteners, gates, inserts, lamps, lane guides, my linear rail mech, posts, sculpts. So I'm gonna go into posts because that's where I think I have that. Yep, there's my offset spade bolt. And we're gonna work from left to right. So this left orbit rail, I designed it so there shouldn't be any spade bolts. We're good there. This next inner orbit rail right here looks like we've got 3. Oh, 4. So let's start working on putting those in. And then what I do to kind of make this easy, so there's that, we'll just leave it where it's at for now. And then I'm just going to create a joint on that edge there. I want to hold, please. Before I do the joint, I'm going to align it. I want to align that there. That there. Okay. Now, create that joint. And then we're going to flip it. There we go. So there's the first one. Pretty easy. I've gotten it to the point where it's a lot easier now. Yeah. And we're gonna do the same thing. We're gonna go over here, insert another spade bolt. And we're going to align. If I do another one of these projects, one of the first things that I'm gonna do is get this. Yeah, joints are definitely a pain, especially like, it'd be nice if the joints had the align features built into it. Because, like, if you want to align something, that's like the most accurate for me to get it where I want it. But then you have to use this capture position thing, which I found out is very bad. So we're going to try to avoid that. Here. Oh. Check my first selection here. So this is the fun of joints. How do I want to do this? So let's do instead. Center of that. Ah, selecting the second. Getting there. Center of that. Center of that. We'll just probably have to do this manually. So you can't do a joint on a line edge like that. Oops. When the line isn't a perfectly straight line, so you can't do like a curve to a curve, or a line to a curve, because it's only going to make that joint at the point of contact. I made these bolts. That should be close enough there. And what I'm going to do, so it's not at the right height right now, so to fix that, I'm just going to say that joint's good for a second, and now I'm going to measure from the surface of that to this, which is the correct height, 0.19685. So if I click that number, it'll copy it to clipboard. Now I can go back and edit that joint. And we're going to shift that down over here. Alright, so that gives me the exact distance. Yeah, Borg Dog, so I did make those bolts. The one thing that I need to do that I'm pretty sure is slowing down this file is I actually modeled the threads, which apparently is also very bad for Fusion. So I need to go back to these individual files for my posts and change it so it's not modeling the threads. But yeah. And one other thing that I might end up having to do, we'll see, is like the goal of this right now, let's see, this hole size is 0.188, 11811. So that's the hole size, and what I'm trying to do with this right now, that's what I thought. So usually when you do a hole on a flat surface, you can click a circle like on another hole or something like that to locate it correctly. So like if I were to try this one, this should be a flat face here. You know, see how it lets me select that spade bolt? So if I click that, it centers it perfectly. And then I can do 0.11811 for my hole size, and that'll put the hole where I want it. That's fine and dandy for the flat surface. But for these curved surfaces over here, I can't select that circle or the hole on the spade bolt. So what I need to do, what I should do right now before I get too far, I'm just going to save this, which is going to take like 30 seconds to save because it's a huge file. But what I'm going to do is open up that offset spade bolt, and I'm going to add a sketch to it on the hole itself, and that sketch will be tied to that file, the offset spade bolt file. So now every time I insert that into my playfield file, I can then use that sketch to extrude that hole, and then I can just extrude it through any surface, whether it's curved or straight or anything like that. That's why I did like up here with these holes are for an opto. So I actually have optos, or my opto file that I made right here. I actually have a sketch buried within that file. Well, let's pick this guy here. So there's a sketch in there. You can see right there, there's that circle. And that is what I can extrude through and create the holes in the rails. And the purpose of this being, so like this one here, if I go and find that one, here, and then activate the flat pattern. There you go. Now my holes are exactly where they need to be. And then I can export this as a DXF, and then I'll send it over to send, cut, send, and the holes will all be where I need them, in theory. So yeah, that's the concept. Let me hide the rest of this stuff again. And I was going to... if I undo show hide back to there, is that my save point? Yep, okay. This gets me in here. I'm gonna open up that Spade bolt file. So I'm gonna have send, cut, send do like the standard angle bends, so like 90s and things like where I can actually give them an angle, but they don't do curves. But my thought is, like, on this one for instance, if I have them do my 90s, and I have my holes correctly located for the spade bolts, then my hole position for the spade bolts should, in theory, help kind of guide the curvature. And it's thinking again. Okay. So, like, over here, if I have them do the 90s for me, and I have those pilot holes in the playfield, so that'll give me a correct position. And then same thing with my spade bolts. If I have a spade bolt right here, and I have the hole in my metal, I can, can't think of the word right now, I can join those two together with rivets, and then I should be able to have that help me guide my bends. So, I'm going to come in here, I'm going to create a sketch here, and I'm just going to project that hole, link, finish sketch. And in theory, that sketch should travel with it. And while I'm in here, wonder how much that's going to screw up though, if I turn off the modeling. I'm just going to cancel that for now. Because I might have some joints that are like referencing the threads. Hopefully not, but you never know. And one thing, looks like I already have a sketch on there. Curious if I come in here and enable sketches. Oh, looks like I already did that. Okay. So, lucky me, I don't need to edit that file. Okay. So, I guess then let's continue inserting spade bolts. And this is why it takes me so long to get stuff done in this, because it's... First of all, I don't know... Like, I don't have a good gauge on how to make an efficient file in Fusion. And by that I mean, when I started this, I built it all within the same file, and eventually started building some components outside of it. But at that point it's too late, and my timeline, you can see how crazy this timeline is. I mean, there's probably 1,000 things in there doing things, you know? Alright, so we're going to... what was I doing? Since that's a curved surface, I'll have to do... joint there... there... and gonna rotate it to roughly the correct angle. Right about there. And let's see, did I still have that copied? Nope, that's the wrong value. So we'll do this again. Measure from the top of that to the top of that. Copy the distance. Go back and edit this joint. And set my Z offset. Go. Click OK. Right. And then one more. Right. Joint. Go. And here. Hit that to the correct angle. Close enough. Set my Z offset to the same value. Okay. And there we go. So there's my spade bolts. And then I guess since I'm going left to right and kind of one rail at a time, I'm just gonna take care of the holes right now while I'm here. Let's go start with the last one I put in. Show the sketch. And then hit extrude. Probably not gonna let me select it. No. So from there, and I'm gonna do distance, the extent type, I'm gonna do to object. Select the back of that. There we go. Alright, so there's my first hole taken care of. And hide that sketch, and we'll move on to the next spade bolt. And repeat the process. Go to extrude. Select the hole. Set my extent type to object. There we go. And move on to the next one. Sketch, extrude. Select the circle. Distance to object. Cut. There we go. That sketch and do the last one here. Extrude. Select the circle. Set my extent type to object. Go. Alright. So that is finished there. And then forgot to hide the sketch on that fourth bolt. Go. Oh, I hit the body on it, that's why. Okay. Alright, so that's that rail complete. Let's check the work here. And update flat pattern. Activate. There we go. So Now there's my holes for all of my spade bolts. Ta-da! And then keep the file organized. So that's the left inner orbit rail left. I'm going to select those 4 spade bolts. Going to left inner orbit rail left. Going to nest them underneath there. That'll help keep that cleaned up. Alrighty. Alright. That one's done. What I should do is, as I complete these, hide them. So that way I know what I still have left to work on. Like this one doesn't need it. And I think that doesn't need it. This shouldn't need it. Those are just kind of supports for the Quidditch playfield. And everything else up there should, except for this guy. Alright. I've got 1, 2, 3, 5. Oh, how? One. Okay. This one shouldn't need one. Yeah. Add that one. And for good measure, I'll just hide these ones too. Yeah. So that's what we gotta get finished. So continuing with our left to right. This one here, I've got most of it ported with an angle bracket. I've just got to do one spade bolt right here. So insert. That's a flat surface there, I believe, so this should be a little bit easier. So we'll create our joint there. Ah, that's right. Never mind me. Forgot to do my align first. Okay, there's the align. So align is useful in conjunction with joint, just because it helps with positioning, in theory. Maybe not in theory. Alright. You know what? I suck. Don't listen to anything I said. I'm just gonna go back to the way I was doing it. That. Set my angle roughly correct. And set my Z offset. We'll just stick with this method, because trying to align that straight edge with the other straight edge perfectly doesn't appear to want to work the way I want it to. Alright, so this is all that this rail needs. Let's find the sketch, extrude it, set my distance, object, there we go. Right, hide my sketch, find this rail here, create the flat pattern, activate it. Alright, there's my new hole. Then gonna drag this up to left inner orbit rail right. Go. Now that one is complete. Alright, next up. We'll do this inner orbit rail. So most of it, like I've got angle brackets, at least for the first part of it, because it's going to take a lot more of a beating with shots coming off that flipper. So I've got on this one 1, 2, 3, 4. Got 4 to do on this one. And I have more on this one because this inner orbit guide and the one over here are like critical that I get the bends mostly correct on them, so it feeds the way I want it to and it's smooth. That's why there's more spade bolts on this up here. Kind of thinking, yeah, I'll just keep going. Let's keep going. Insert another spade bolt. Okay, create a joint. There we go. And there. Go to a top view. And I've set the angle. Pretty good there. Set my Z offset. Yeah. Oh, there's that one. Insert another. Alright, same process. Create a joint, make sure that you can see that origin kind of snaps to the center where I want it. Then come over here to this one, top view, set my angle. My offset. Click OK. Good enough. Another. Inserted. Create a joint. Make sure my origin snaps to the center. There we go. Okay. Get my angle kind of adjusted here. And this doesn't have to be perfect. It is a curved surface. So it's not going to be perfectly matched angle-wise, but I want to get it close enough. If it's off by like 1/100th of a millimeter, who cares? Pinball, it's going to get beat up anyways. Alright, one more. Into current design. Mom. Ooh, we dropping frames. Huh. Let me shut off my preview. See if that helps. Yeah. Dropping some network frames. Not rendering lag, but network is being funky. If anyone is still there, let me know if it's a problem or not. Okay. That point. And find the last one there. Go to a top view. Hopefully it's not too laggy. Thanks, Kevin. Yeah, like, I don't... You probably know more about this than I do. Like, when you go into your stats section, I don't understand, like, like, what stats I should be looking at to be good as far as lagginess and whatnot. Because there's like skipped frames for rendering, skipped frames for CPU, and skipped frames for network. But I don't know which affects the actual quality and skippiness. Yeah. Alright. So that spade bolt's good. Now we go through those 4. And start going through and extruding those sketch holes. When's the last time you extruded a sketch hole? Eh? Sounds dirty, doesn't it? Alright, there's that one. Gotta do this 4 times. On here. Sketch hole. Set my extent to object. Bing, bang, boom. Hide the sketch. Go to the next sketch. Man, this is some sketchy work, isn't it? Through this one. Do object. Cut. Okay, that one is done. Now let's do the last one. And extrude. Set my distance to object. Bing, bang, boom. Alright. So all those are good. Now let's check my flat pattern. Hopefully it didn't ruin it. Errors in flat pattern. It ruined it. So this is the joy of Fusion 360. Flat patterns. Hopefully, yes. So sometimes, with the sheet metal flat patterns on where I have like an elongated curve. What's up, Mr. Kennedy? The brew is going. Welcome. Welcome. It's going slowly. But I'm getting so close to a whitewood, I can taste it. So sometimes when I create flat patterns for my rails, if it's like a large radius curve, or if I have like stitched together different radius curves so they're all tangent to each other, sometimes when you create the flat pattern, it can't flatten that out for whatever reason. and it gives you a curve in your flat pattern, which you don't like. So I always come and check the side profile to make sure it's actually flat. So you're going to see this one's updated with all of our new spade bolt holes. We'll finish. And then that's that inner orbit rail, so let's copy all those spade bolts onto that component so it's all kind of tied together. Makes it easy to hide when I don't want to see it. Alright, done with that one. You can see on my whitewood I have a groove cut in here. I did that for some of the critical rails and it's only like a 1/16 of an inch deep, but I did that to give me a guide to my curves as I'm bending them, just to make sure that I can get it as close as possible, because the curves that you see on these rails are what worked really well in Visual Pinball to make sure it all fed the way I want it to. So, like some of these rails, like especially this inner orbit rail, I have that groove that I'm gonna kind of notch out in the playfield just to make sure that I can get it as close as possible. And then from there I can fine-tune things. That'll at least help get me started. Next is, we'll do this one. I have, looks like there's two I gotta do here. Insert number 1. Okay, joint. I make sure it snaps to center, there we go. And let's create that joint here. Go to a top view. And that should be kind of close. There's probably close enough. Still seems a little off. We'll just leave it at 135. Set my Z offset. There we go. Woo! What'd I do? Something happened. I don't know what just happened here. Alright, we might be caught in a waiting period here, because I must have fat fingered something. I mean, it's doing stuff, obviously. Like you can see the left tree over there jumping around. So it's like going through its steps, working its way through the timeline. I wonder if I must have like dragged a timeline item. I must have dragged a timeline item around. Sorry, my dogs are playing right now. Okay. Operation canceled. Let's just step back one here. Usually I can't hit escape and cancel things like that. I don't know what I did, but I have notoriously fat fingers, so what are you gonna do? Alright, take two. Rotate in. Go. Set my offset. Click OK. Alright. Now we're back. So if I wanted to like be exact with this, I can. And the way I would go about doing that is I would measure this face to, if I can find it, to that face. That'll give me an exact angle. So 1.52557. If I go back and edit my joint, I can we'll just do this plus, that go the right way or the wrong way? Minus. So right there would set it exact. And I can do that for this one since it's a flat surface. Okay, we're gonna do this one here. Thanks for staying with me here. I've got a few more to go. And then once that is done, we can start working on the wood screw pilot holes for the backside of the playfield. And then, once I get the pilot holes done, I should be able to start creating the toolpaths for the CNC. It's a hard word to say, toolpaths. Toolpaths. I may also just be an idiot. And of course I don't have my number copied, so I gotta go figure out my offset again. So, top surface of this one to 1. Copy that back to my clipboard. Let's set the Z offset of this. Okay. So those are those two. Now let's go down to those spade bolts and start extruding the sketch holes. Oh, there's that one. Extrude that to the inside edge of that. Okay. Hide that sketch, do the next one. Do the same thing. Kinda hard to get this exactly right so you can select that hole through there. Go. And set my distance to there. Alright, and that one is complete. Add that sketch. Check this rail. Oh, I'd never create a flat pattern for this, so let's do that now. check to make sure it's flat. It is. Ish. Alright, now copy those spade bolts to this rail. This rail is called the Denisi lock rail. I recently changed this portion of the playfield. Because before, this whole area right up in here, it had like kind of right where this hole is, it had like a subway entrance gobble hole thing. And then it had two stand-up targets to the right of it. So kind of like almost a mirror image of JJP's Pirates, where you have this inner orbit shot right here, and then there's a hole here, and then two targets here. And one... Excuse me, I don't bark while you're talking. So yeah, I had that hole there, and I had two stand-up targets there. And there were a couple issues with it. The hole isn't perfectly centered over the subway. I also didn't like that I had that subway entrance hole right next to this Flu Network VUC, which is also a subway entrance hole. I didn't like having two of those just so close to each other. I felt like that was almost redundant. So I kind of wanted something different, and I figured out that I could actually squeeze in a ball lock here. And I messed around with that layout probably a good 3 hours or so, trying to figure out what I could fit there and what I couldn't. And eventually what I settled on is this kind of Denisi style lock from DNA, in a way, where you use the drop targets to lock the balls. So, let me go up here and show my mechs. Show my target. And posts. Posts and spacers. There we go. So this is kind of what I landed on. So I still have that outer orbit shot, but instead of a hole being right here, I added this rail. I made sure there was plenty of space behind it for that orbit to work, and my kind of like mini ramp that goes into that orbit as well. Make sure that all works. And then I'm thinking it'll kind of work like you knock the target down, you knock the next target down, and then once you get a ball to go up and hit this stand-up target, then it'll pop up this drop target and lock it in place. And then to lock your second ball, once it shoots up here and hits the front of this target, it should knock that ball back into this stand-up again, and then I can register the hit and then pop this drop target up. And then behind it is going to be a star rollover switch insert to sense that I actually have that ball captured. And then that star rollover is also going to be used so to start that multi-ball, you would have to hit the front of this target, and it would knock the ball off of that star rollover backwards this way. And the second that star rollover switch is back open, then it would drop all two of these smart drops. So, and then I was able to keep one of the stand-up targets here. We'll see in the end how well it shoots. off of this flipper. I mean, I think the orbit's going to be really easy to hit. That's plenty wide enough gap for you to hit that shot. But we'll see if this ends up being too tight. Maybe I gotta take the rubber off this post too to help make that a little bit of an easier shot. We'll see. But yeah, so that's that design, that new design there. Alright, let's go back and hide my mechs and switches and posts. And we're done with that rail, so let's hide it. There we go. Alright, let's do this next inner orbit. So I've got one there. Two, three, four. So, 4 more on that one. Do that. Insert into current design. I want to make sure. Okay. Just making sure this is on shuffle, this playlist. Okie dokie. Let's go. Come on. Stop thinking. Do what you were born to do. Model pinball. Okay, there's that joint. And that hole there. Let's set the angle. Back just a little bit. Come on. Good there. Set my Z offset height. That's 1. And let us insert number 2. Go grab the joint here. There we go. There we go. Get the angle kinda matched, close enough. Huh. See that weird circle kind of come in? I did it again, I don't know why. That happened the last time everything started freaking out on me. I don't know what's causing that. Anywho, it didn't cause it this time, so let's insert another spade bolt. Click OK, create my joint. Oh. There, should be good. And get the angle set close. My offset. There we go. That's 3. Let's insert number 4. Okay. let's grab it for my joint. There's my snap origin. And let's have that. Go. And get my angle kind of set on that one. Set my offset. Click OK. Alright. Well, that's the 4 spade bolts for that one. Now, same process. Let's go one at a time. Oh, keep orbiting. There we go. Let's start extruding these holes. At my distance to object. Close enough. Okay. Offset bolt number 3. And let's grab that hole. And set my extent to the other side of this rail. There we go. I'm sure there's a much better process for doing this that the manufacturers use. I'm sure their CAD skills are far better than mine. Although I would say that mine are pretty decent. But I'm giving myself a pass on this one just because this is a new software for me. This one might be an issue. Yep. Okay, so I can't quite cut that one yet because apparently I forgot to extend my tab down. So we'll come back to that one. This top one. Do the hole here. Yeah, I mean, like, there's things in my mind, like, I wonder how the manufacturer CAD people do it. Like, for me, the problem that I struggled with was trying to create metal ramps. Like, ramps in general, yes, and I figured out a way to do my ramps where I can create a buck and do some thermoform plastic, but trying to create the sheet metal for that, where like the tabs all kind of lock into each other. If you look at any like the stern ramps, they've got kind of little slots, so when they piece it together, these tabs stick through and then they bend the tab to hold it all together and hold the shape. I've struggled with trying to figure out how to do that correctly. Okay, so this one was a problem. So what I'm going to do, create a sketch on the top of that rail. Of course, it just gets all crazy on me. Alright, and then I'm going to project top of that rail. And then I'm going to also project that line there. Center my hole. And then I'm going to offset that line. We'll say, yeah, 1/4 inch each way should be good. Offset it again. Go. Trim that side. Trim that side. And then extend that to where it meets there. So there's the profile that I need to. Let's finish sketch. And then we're going to extrude that. And then I'm going to reference another one. So we'll set my start point as an object. And that object is going to be the bottom point there. And distance is going to be to object there. There we go, you see it. Put that tab in there. Okay. Now I can extrude the hole. Distance to object. There. There we go. Alright, so that is all 4 spade bolts, I believe. I got all the holes. Yep. So, I'm gonna go check the flat pattern for this one. Alright, error updating. So now I gotta create a new one. This should be my flat point here. That last edge there. Let's see if let's try this again and create it from the other side. Come on. Alright, create a flat pattern. This flat here? Or no, not that one. This one. That definitely didn't work. Look at that. So that's not a good thing there. This should be flat here. This is the issue I was talking about with flat patterns, is trying to get it perfectly flat. It can be finicky. Same issue there. This one might be flat here. Hard to say. That one might be flat there. Try that one. Worst comes to worst, if I can't get this exactly the way I need it. That didn't work. I'll go with the closest one, because even if it's got this little bend back here that's off, what I can do is like chain all these edges together in a selection. And they'll tell me. That tells me the total length of that is just over 18 inches. So then I can go in and edit that DXF and fix this end here. What I might end up having to do. I tried that, I tried that, I tried that. I guess we'll just go back down here and... It's messed up, it's messed up. Yeah. Something at this end doesn't like... It almost has like a little inward curve there. So it seems to be starting with this one here. But it is what it is. I mean, in theory, all of those curves should be tangent to each other. At least that's the way I designed it. Just sometimes it screws itself up. I think I deleted those, maybe. And I had other component files out there that had the sketch profiles for these rails, but I deleted them. Oh well. I can work with it. So, I need to copy those spade bolts up to inner orbit rail, right? Alrighty. Now I can hide that one. Alright, let's do this outer orbit rail. I've got 1, 2, 3, 4. Looks like I gotta do 4 of them. 5. Yeah, and like this down here. It's gonna need the same treatment. Okay. What are you gonna do? So, insert spade bolt. Alright, let's create my joint. Oh, you know what I forgot to do? I forgot to, set up my now playing thing. Let me turn that on after this. Is that a Cuphead song? It was. It's some great music with Cuphead. Is my offset value still copied? Yes, it is. Hey. Alright, let's turn that now playing on real quick. Oh boy, my desktop got all messed up again. There we go. For your viewing pleasure. Alright, I'm going to disable my preview again. Okay. Let's insert more spade bolts. Because who doesn't like a good spade bolt? And get my joint. And right here. And close there. Set my offset. Alrighty. Yeah, let's do 3 more. Alright, joint origin there, and joint there, top view, state that correctly. Close enough. Offset set. Insert another. I'm a little worried about this outer rail getting messed up again, just like my inner rail did. What I should do is go export that DXF now before I do my holes. That way I have kind of a copy of it. I think I may have already done that export of that DXF, but need to check. Set my offset. Click OK. Come on. Go. Let's insert the last one. Click OK. Create my joint. Add my joint there. Close enough. Set my offset. Alright, that's that last one. Alright, so I wanted to go through. Let's make sure that I actually have this flat pattern. See, like right now it's perfectly flat. The way it should be. So I'm going to Powder Homebrew. Can I open this with Fusion? Right, outer orbit guide. That is that one. let's do this. Let's go to my Harry Potter Homebrew. Let's create a folder called EXF files. Let's see if I upload that here. It'll let me. Really, I want to check and make sure that this is the right good file. Alright. Okay, so this doesn't have my hole in it for the opto. Well, let's re-export this. Unexpected problem. Me. Huh. Well, son of a nutcracker. What I could do this. Create a sketch on it. Then let's just reject that whole surface. Reject all my bend lines. And what I'm going to do is see if I can export this sketch. Of course, it didn't project my surface. Go. Finish sketch. Save as DXF. Alright, worked that time. Alright, so that'll at least be saved and allow me to have kind of a backup if this does get screwed up. Alright. There we go. Now it's got the hole. I can go through and mess with this to figure out what my bends need to be, if there's any hard bends in this, which there are not. So that one will just be a flat cut. Alright. Delete the old one there. Okay. Alright, so I need to extend the tab around this one here, so let's do that now. Let's create a sketch on the top of the rail. Then let's go find that spade bolt and turn the sketches on. And then we're going to project the surface. And project that center line. Close enough. Five. We'll offset 0.25 the other direction. Trim. Trim. Bend those lines. There we go. Didn't extend that far enough. Go. And I'm going to take that and okay. Looks like I already have it kind of extended there. So let's go back and edit that sketch real quick. And I'm going to just draw a line from that point there to that point there. Delete that one. Now this should meet up. Theory. Extrude, starting at that point, distance to that point. Here we go. Alright, now let's go start doing the holes on this. I got 5 of these holes to do. Fence 2. Go. Hide that sketch once it stops thinking. Once it stops thinking, next. That's right, these are inside for whatever reason. Should be fine. Shouldn't affect the ball travel. This one might have to be distance because it looks like... Oh, I can do 2. Right. That sketch to number... And let's extrude. That one. Fence 2 object. That one there. And hide that sketch. And sketch. Did that one. Oh. To open up the next one. Alright. Extrude this hole. Distance to object. That there. Hide. And the last one. And let's extrude that sketch hole. Distance to object. There we go. Hide the sketch. And let's go check the flat pattern. Alright. Looks like it added those holes there on the projection. See? And it looks like it added that extension on my projection, which is handy. If I were to export this to DXF, it's... No, that's what I tried last time, but it didn't like it. Call this number 3. Attempt number 3. See if it gives me an error still. Yep, okay. So we'll just export the sketch. Okay. And let's upload that sketch. I'm very curious how much these are going to cost to get made at Send Cut Send. I think on Steve on Pinball Room said they were like $12 each or something like that, with bends included. Who knows? Oh, I can delete this other one. There we go. Outer orbit rail. So let's get all these offset spade bolts copied up to that. Right, and then I just have one more to do. That'll be all the spade bolt work complete. Alright, last one. And it's just a single spade bolt. Easy peasy. Let's go back to my assets. Posts. Bolt. Dirt. And let's create that joint. There and there. Get my angle set. Almost. That's close enough. Set my offset. Lock it in place. All. Alright, and let's extrude that to object. There we go. Hide the sketch. Check my flat pattern. Yeah. Let me even activate it. So there's the current. Just for safety. And then let's recreate this since it won't let me update it. Alright. Looks like it worked, so let's do it again. Oh. Yeah, okay. Looks like it didn't work. Alright, same deal. Create a sketch. Let's do a projection of that, and a projection of my bend lines here. All the rest of that's gradual curve. Right, finish sketch. Then let's export it and do that. Yeah. Now, if I go back to my DXF folder, come on, and let's upload that. Yeah, man. There we go. Alright. Well, at least we have that one. Alright. Copy this up to that. That should be all the spade bolts. Here we go. Okay. Don't really care to see that. Alright, rails are done. Let's... Shouldn't need those for the backside mix. Yeah, our backside holes. So that's there. There was something else I wanted to check. Yo! What's up, NS Pinball? Thanks. Appreciate it. Thanks for the bits. Hope you're doing well. I'm going through and checking hole stuff now. I just finished with guide rail, spade bolt locations, and updating the flat patterns for the guide rails. 09375. 09375. Alright, I got that hole correct. I didn't think I did. Alright, good enough there. Thanks for the bits, so I much appreciated. Hope you're doing well on this Saturday morning where you're at, or afternoon. Should be right on the border. Yeah, so I got that done. So kind of the last big step before I can start creating my toolpaths is it is hard. I don't know, how much of this have you seen? I can give you, let me start popping everything in here so you can see where it's at. Oh, first time. Well, welcome. This is how far it is. It's a bit much. Although I don't know why this isn't looking like glass. That's annoying. Glass light color. Anywho, not assembly. Orb. I wonder if I set the appearance somewhere else. Set it to polycarbonate clear. There, close enough. Right? Well, so I'll kind of give you a rundown then of my goal with this game. Ultimately, my goal is, I mean, obviously a world under glass, right? But I want it to feel magical because of the theme, right? So part of that magic is kind of what I tried to do throughout the design is make sure that every single shot can have multiple outcomes. So like every ramp shot can have multiple outcomes, every orbit, every you name it shot can have different outcomes. So there's a ton of diverters in here, there's a ton of magnets in here, there's a whole subway underneath. I call it a subway circuit that is self-staging. So there's, if I recall, well, I'll just go about it this way. There are three possible exit points from the subway, and I think there's like 5 entrance points, something like that. And the whole thing is designed so that I can have balls staged in every VUC, and that way, like, let's say for instance, if I shoot this VUC back here, I can have one immediately pop out over here. So that would kind of be representative of the flu network. So the goal with the subway system is to be able to just instantly pop balls up everywhere and then manage the staging underneath. Thanks. Much appreciated. It's been a lot of work, a lot of custom design. There's a ton of different custom mechs in here, each of which took, you know, weeks to design correctly. Let me hide the sculpts so you can at least see a little bit more mechanically. A little bit more mechanically what's going on. So shot-wise, you've got over here, this is going to be kind of like your Ministry / London shot. It might be a mode start, I'm not sure yet. Just to the right of that, you have the left orbit, and that left orbit can either feed back to the right orbit, or it can go up this rear ramp to what I call the sorting hat diverter. So this is kind of like designed based on like a railroad turnstile. Yeah, it should be located similar to the depths of POTC. It should be kind of a similar feel shot. I might change a little bit on it though. So like right now it's just kind of got this flat rail over here, and it'll also from there eject and feed down to your flipper. But I might, to make it a little bit cleaner shot, I might build like a bent rail, like a curved rail right here. And then out of the buck, hey, thank you for following Pinball Shenanigans. Welcome. Yep, so there's inspiration from many different games in this. But yes, the furthest out lanes are not actually out lanes on either side of this, so this is kind of POTC inspired, where it falls down here. But I also give you a chance to kind of like nudge save it. So there's a little bit of a post right here, and if it comes down and hits that post, you can nudge it up through this one-way gate right here and back into your flipper. So we'll see. Yeah, so the magnet thing is something that because I didn't know about Bram Stoker Dracula. I didn't know about that actual mist multi-ball. So I designed this before that, but it is similar. Is actually underneath here. So it's driven by a stepper motor and a lead screw. And I created a whole... Let me get around this way. So I created a whole linear rail system with a mount for a magnet. And I can precisely control the positioning of that magnet. I can also, depending on the speed of the stepper motor, I can, in theory, kind of fling it. But that will allow me to do a couple different things. The original inspiration came from the idea of I want to create moments. So if you think like Goblet of Fire, when Harry and Voldemort, their wands connect for the first time. So what I want to do with that magnet is you'll launch a ball out of this left shooter lane. The magnet will grab it, and the light show will show like the beams of their wands connecting. So you'll have like green come in and red come in, and it'll meet right at your ball, and it'll be like kind of a power struggle, just like in the movie where the ball moves and so does the light show to correspond with it. And that'll be like that moment when the wands connect and everything. Whether or not I pause gameplay for that is yet to be determined, because I don't want you to like, because that magnet's going to be on for a while, I don't want you to have another ball stick to it type of thing. So it might be just a temporary little pause in the show. But yeah, so that's the concept of that. And that's back to your question. Yes, left out lane is actually a feed to the flipper, and then the actual out lane is the next one in. You can bump it off of this post here, up through the one-way gate and back to your flipper. On the right side is subject to change. I did kind of take a little bit of the save from Pirates there as well, but one of the features I have on this game is going to be unique. So if I go to top view, so you can see right here and here are two magnets, and this is what I'm going to call the Dobie ball save, or Dobie assist or whatever. So when your ball comes down here, I'm either going to have a switch behind this rubber or a target up here and force you to nudge the ball up into that target, and that'll activate that ball save when it's qualified. And these magnets will be used to accelerate your ball along this rail and, in theory, back up the other out lane and back into play. So this is all like, the geometry of this is made so that it should feed up cleanly out of here. That'll take some fine tuning, I'm sure. But that'll be like kind of the Dobie ball save thing. So yeah, the left orbit shot can feed up this back ramp to that diverter that I was talking about. This left inner orbit is, again, sticking with my process of every shot can have multiple outcomes. So you see like these forks right here. I stole that design from the chest in Pirates. But these forks will pop up and essentially turn this into a ramp that feeds. This is the Green Gots ball lock. So it'll come up into here, it'll lock 3 balls in here. That's within the Green Gots building. But when you don't have lock qualified, it'll just flow the ball through it and onto this wire form, and it'll act kind of like a left ramp. And then when the forks are down, which is going to be a majority of time, it goes up into there. You can see I have this little incline ramp, and that incline ramp feeds. I'm just going to hide the Quidditch playfield, and I'm going to hide the drop ramp for now. Okay. So that incline ramp actually feeds this inner orbit, which comes all the way around to this upper flipper. Yeah, I mean, I very highly doubt that anyone is going to be interested in this design, just because it would cost so much damn money to make, and also because, from what I understand, J.K. Rowling doesn't want to see Harry Potter turned into a pinball machine, but I'm allowed to do so under Creative Commons, so it might just be a one-off thing that I do and everyone else can dream that it would happen. But I also really, in the back of my mind, hope that if I do this right, that there's a small chance that J.K. Rowling sees it or catches wind of it and says, you know what? That could actually be really cool in a pinball machine. And at that point, anyone can pick up the license and do their own version of a Harry Potter game. So if anything, I just want this to open the door so that a production machine can be made by who knows who. But yeah, that would be a dream. I don't really have aspirations to get into to get a job out of this or anything. I mean, if that were to happen, then I would consider it. That would be cool, but I'm not making that a goal because I don't know if that's entirely realistic, so well, who knows. But either way, this little ramp feeds up into this inner orbit, and that feeds around to the upper right flipper. I'll go over the upper right flipper shots in a minute. Also, in this inner orbit, there's a magnet in the back here that can grab your ball, drop it down into this, which is a isolated subway that feeds the Quidditch playfield. You can kind of see it here. So it feeds in there and over to the buck that feeds the Quidditch playfield. So yeah, that's the left inner orbit shot. And then just to the right of that, I call this Horcrux Pizza, just because it's pizza shaped, but this is a captive ball lock, if that makes sense. So this bar right here is actually a mech that lowers down that bar, so you can kind of see it right here. So normally this bar would be in an up position, and then when you're like hunting for Horcruxes and you gotta like obtain a Horcrux, at that point when the ball hits a target back here, this bar would lower down and it would capture the ball. It would be a captive ball in here, and for destroying the Horcrux, I'll require you to shoot that captive ball. And it's a pretty dangerous position because, you know, a bounce off of that could come right back down the middle. So I want there to be some strategy to that shot, especially with it being so important as, you know, in the story and the lore of destroying Horcruxes. It's a big moment. So I want there to be risk-reward with that shot. The next shot to the right of that, off of the right flipper still, is straight up into, you can kind of see right up here, straight up into this Vuck, which, again, I would have the ball like instantly pop out over here to feed your left flipper. So it's, in a way, it's like, it's the Flu network, but that's like a kind of a left ramp, in my opinion, without it being a ramp. The next shot to the right of that is this center ramp. That feeds up to my sorting hat diverter. And then I guess you could also backhand from the right flipper up into the dungeon here, which is 2 pops and a sling. And it can bounce around up and in there. It can drain out of that dungeon back to your right flipper. Or it can drain back out the center here. I have a proximity sensor behind these drop targets, so if there's a ball that gets kind of stuck in there, I can let it out. You can also, I think if I recall from Visual Pinball when I was playtesting this, you can also backhand this shot underneath the right ramp. So that's everything from the right flipper, and then we kind of move to the left flipper. Left flipper shots, you have these drop targets here. You've got the dungeon shot up into here. The room of requirements is behind this drop target, and that's actually a shot that passes through the inner orbit and goes into the back orbit and then eventually drops into a subway. So that's like your extra ball shot through the pops. And then the next shot over from there is this turnaround behind the right ramp, and that again feeds your right flipper. So I wanted that right flipper to be able to be fed from either of the flippers down here, so you have a shot off of your right lower flipper that comes around the orbit to this, but you also have a shot off of your left lower flipper that comes around this turnaround to this. Then there's the right ramp that goes up to the sorting hat diverter again, and from there it can either come all the way around and out your left orbit, or it can go, if I recall, I gotta think through all the combinations here. I think it can come, yeah, it can come back down the center ramp there. Or it can feed a wire form. There's going to be 2 wire forms coming off right here. There's like probably 50 combinations of shots with this diverter here. I think that'll be really cool. And then the next shot over, you have this inner orbit shot, spinner that I talked about before. This is probably my favorite shot in the game. So when you shoot this, it actually goes all the way around this, and then it comes down here and actually feeds to your right flipper. So it goes up through this orbit, down here, and it shoots down and gets collected on your right out lane, and then again skips over to your flipper. So that is a really satisfying shot when you hit it in Visual Pinball, and I gotta tune that in this game so it's also just as satisfying. And then the next shot to the right of that, you have what I call Hagrid's Hut. Yep, I actually started by building this in Virtual Pinball to come up with a layout that I really liked. And then I've been, over the past probably 8 months, transferring that over to Fusion 360 and actually catting it up. That's been a lot of work. So this is the Hagrid's Hut diverter here. It's not a spinning disc, but it's a rotating disc. It's a rotating target bank right here that also turns into a outer right orbit shot. So also there's an under the flipper shot right here that allows you to enter Hagrid's Hut, which is, there's a subway entrance here. But this would be like your Dark Forest shot or Forbidden Forest. When that orbit's open, or Hagrid's Hut, you can hit the targets and enter his hut through the under the flipper shot. So that was like the first custom mech I designed. Something else I wanted to do, because wide bodies can be slower playing games, or they seem slower or more floaty with those wider shots. So on both of my outer orbit shots, I'm actually going to use a magnet to accelerate the ball around it, so that way it feels more speedy. One other thing that I have hidden right now, let me find that, is this drop ramp. So this drop ramp allows me to gather the ball from either of those right orbit shots, and I can either have it pop into the left outer orbit. So like if you shoot this right inner orbit, it can not only come down and feed here, it can not only get caught up by the Quidditch ball lock, but it can also go up this drop ramp and then out your left orbit, or it can go up this drop ramp and down this wire form here. So that one shot has 4 possible outcomes, which I think is going to be cool. And then the same with the outer orbit, is I can grab the ball out of there and feed it down this left wire form. And then a little bit further down here, you're probably wondering what this weird thing is down here. This is the Whomping Willow. And this is also a custom mech that took a lot of engineering. So this custom mech is like, it does 3 or 4 different things. It's a spinning disc, like a free spinning disc, so you can hit it and spin it kind of like the GNR hat, whatever. It's a powered spinning disc, so depending on the mode state, I can engage a drive wheel and spin it. Or the tree that you see on there, the Whomping Willow tree, is going to be cast silicone, and buried inside of it is a mechanical armature that will actually whomp the tree branches. So like it can lower the tree branches to impede your ball, and those will act as your posts on like a free spinning disc, so you can hit that lowered tree branch to perpetuate the spin. so it can whomp your ball. And then, lastly, this whole thing, I don't know if you're familiar with the lore of Harry Potter, but under the Whomping Willow, there's a knot at the base of the tree that they would tickle to open up the passage to the Shrieking Shack. So there's a passage underneath the roots of the Whomping Willow. So this whole spinning disc assembly actually raises up out of the playfield, and there's a whole dish that can collect your ball into the subway. So there's that. Well, hey, I appreciate that. I don't know how far I'll be along with an actual physical prototype, if it'll even be worthy of anything at that point. Your 50K estimate may be low, depending on today's market. There's also a target right here, so you remember that cool little figure 8 combo shot that feeds down here. So ideally, I want it to feed cleanly at full speed down to your right flipper, which is a really fun, like, speedy shot because it gives you more kind of tip of the flipper shots, which make that Ministry London scoop on the left there a little bit more accessible. But if you underpower that shot or it rattles around too much, then it can come down and hit this target right here, and I can use that to engage the spinning of this disc to mess with your ball. So it's kind of like its own little pop bumper sling thing. So yeah, so that's that. That's all the shots. The sorting hat diverter also has a magnet on it that can grab your ball, and then it can suck it back up into the subway. So on the back side here, get everything oriented. So like it can actually grab your ball up there, and the sorting hat can make a decision on where to send it and whatnot, but it can also suck it back up into this VUC. Additionally, that VUC is connected to my subway, which allows me to feed balls up to that sorting hat diverter, and that sorting hat diverter feeds my Hogwarts upper playfield as well. So you can kind of see, like right here, there's another wireform attachment that'll feed to Hogwarts playfield. So now we get to upper playfields. Let me find Hogwarts. So Hogwarts is very roughly shaped on how I think it's going to be. This kind of comes later in the process, but so a ball will feed right off of the sorting hat diverter into this. It'll roll down this rail, bump off this post, and should kind of volley it over to your flipper and get that in play for you. I can also feed that upper playfield. Remember that the Flu Network shot back here? The scoop is actually going to be up a level, so I can eject a ball up to that Hogwarts playfield at any time, and I'll have that feed to your flipper. 3 targets up here, and then this inner rail right here, what I want to do is put kind of a curved ramp that flies you around through Hogwarts and then like up over this roof line and feeds a little wire form that comes back to your flipper. So it's kind of like its own little orbit loop thing. And then when the ball drains off that upper playfield, it goes all the way over to this hole and drops down to your right upper flipper. I'll have like a wall right here that's a clear piece of plexi or something just to guide it over. And I want this to be, it's going to be made of polycarbonate because I want you to be able to see everything, every shot underneath. And it also kind of goes with the theming of flying and your ball kind of floating above the playfield, so there's that. So that's the Hogwarts upper playfield, and then lastly there's the Quidditch upper playfield. And this Quidditch upper playfield is very, very unique in design. I don't think it's ever been done before in the history of pinball, but this whole playfield right here, including this flipper and this spinner, actually is, it's clear polycarbonate, and it's attached to lead screws that are buried within these grandstand towers. And that whole playfield raises up and down while your ball is on it, and you're shooting these like Quidditch loops. So I think I'm going to use that spinner to actually control how fast it moves that playfield up and down. And ideally, with every spinner rip, it's going to raise it up some, and then as time passes without a switch hit up there, it lowers down. But your goal is going to be to rip that spinner and raise it up to where you can shoot the scoring hoops. And these scoring hoops have actual optos within them, and they can sense when the ball passes through them. That was a custom design too. And eventually I think like you'll score all three, and that enables an extra ball, which somehow you're gonna try to hit the snitch or something. I don't know. I don't have a snitch up there, but I have some ideas for that. Yeah, this whole thing raises up and down. So if I had the sculpts, you can kind of see the design on that. This took some serious thinking because flippers are typically stationary. They're attached to the actual mech. So what I had to do with this is I have the flipper bushing attached to my playfield, and I'll have a custom shaft for this flipper where it's actually, it's a short little snub shaft, and it's got an E-ring on it to hold it in place, so it just kind of rotates freely on that bushing. And then right here is the actual flipper mech bushing with, I'll take a rod and bend that into shape, and that rod will actually kind of like push that flipper as it raises up and down. So that allows me to flip the flipper the whole, I think it's like 6 or 7 inches of travel. Yeah, that'll be cool. I think I have an animation of this somewhere. Alright. Well, here you go. That's what it'll look like. Isn't that cool? So yeah, I'm excited to actually get that built and working. That'll be super neat. I also have an animation of the Whomping Willow. Show you that. So you can kind of see the shaft moving up and down. That's what will undulate the arms on the, or articulate or whatever, the arms on the tree. So right there, if you watch like the top up here, you can see that moving up and down, and that'll be attached to some like skeletal arms inside of the silicone. And then you can kind of see, let me back it up again. Back it up again. And you can see when it rotates to the underside here, it shows this is like the drive wheel right here. So that that's just an idler pulley, and that's attached to a DC motor, and that'll allow me to spin the wheel when I want to. But you'll see, if you watch carefully, it kind of rotates into position like 2 degrees right there, and that's the engaging and disengaging of that drive wheel. And this is like a 2-way coil, so I have, there's this shaft, there's like a stainless steel tube, and then there's the actual shaft that goes up through it. the shaft that goes up through it gets sucked down to articulate those arms on the Whomping Willow. And then the tube, when I activate this top coil, will actually push the shaft and the whole assembly up out of the playfield. So that's what you see at the end here. So there's the shaft, and then here comes the tube. You'll see the whole disc lift up. Right there. And that's what opens up the passage. So yeah, that's the Whomping Willow mech. So yeah, that's the overview. That's the rundown. Any questions? There will be a test. Oh yeah, and then the underside gives me nightmares. But it all meshes, it all fits together the way I want it to. That's why it took so long designing this up front in CAD, because I had so many ideas I wanted to incorporate. I had to make sure that it all physically could fit underneath before I got too far. And now I'm way too far. But it all fits. That's been the goal of this. I have not done a coil count. But, I mean, look at this upper cluster up here. I mean, there's a ton going on. Plus every VUC has 2 coils. That's because of how I designed it to manage the balls in the subway. But yeah. Oh. Just makes me uneasy looking at it. Anywho, so what I need to do is I'm going to continue working on this, and the last part of what I was going to try to do before I start figuring out the toolpath for the whitewood is the pilot holes for the underside. Right? Oh boy, where do you even start with this? So, I need to, for these pilot holes, I'm gonna hide the sculpts, or they're already hidden. I'm gonna hide the Hogwarts upper playfield, I don't need that. I don't need the other upper playfield, or the ramps, or the plastics. Don't need the ramps, don't need the insert, don't need the wood rails, or the wire form. None of this. Oh, nope, I do need that, because there's one bracket up in there. Don't need any of my ball guides. I'll be topside. I need my switches and gates. Posts and spacers I can actually do without. Because what I'm trying to do here is I'm going to create a sketch for the pilot holes for all of my number 8 screws. So, create a sketch. Profile plane is going to be the back side of the playfield. Oh, and I'm sure I'm gonna miss something. So, hit P for project. And I just need to go around and start getting all the holes projected. I think I'm gonna just kind of do this in like quarters of the playfield at a time here. Get everything on my custom trough. And the reason why I'm creating a sketch is because if I have a sketch with multiple hole points in it, A lot easier to create the actual holes because I can select all of them at once. Let me grab the other holes from the subway here. So there's that. Need to get that third hole there. These two. Can't quite reach the one under there, so let's go hide my subway. Don't need that housing. Don't need that. Okay. Makes it a little bit easier. Alright, there's that hole there. Let's finish the rest of the subway mix. And then what I'm going to do is, as I complete these, I'm going to start hiding them. So it makes it a little bit easier every time. Okay. That one there. Can't remember if this is there. Where else do I have that bracket? That's right, that sneaks in under there. Can't quite get to that other hole right now. Suppose I could do this left flipper. Or right flipper? And the other two. And then hide that flipper. Oh, not that one. Nope. Nope. Oh, that's right, it's a diverter. Hold, please. Okay. Now I can get at that other hole. And you might see some like overlap on components. That'll all just be, I can fine tune that stuff later. Alright, so that's that part of the subway. I got all the troughs done in the subway. I should be able to hide that. Alright. Just gonna click OK. Make sure I don't lose any of those. Sometimes when you do projects, doesn't always keep the ones you selected for whatever reason. Alright, looks like we got that. That should be all good. Alright, starting to clean up. So, to continue with the process, I'm gonna get these out of the way. I already got one side of them. Alright, let's take care of those. And let's get these. I'm just kind of systematically working through each group. Make sure that I get everything. The screws on the bottom here. And that VUC got misaligned. I gotta adjust that. Alright. Here's those. Back up. What is that? I don't want to see it. Figure it out. Oh, those are those guys in the front. Alright. Those holes. And those I believe are through holes. Alright, now I can all those back on. Hide the group. Well, looks like I already have those through holes. Guess next let's take care of the flippers. So let's get these holes. And these holes on the left flipper. Ready? Take care of this flipper. Which this one's probably going to need a little bit of adjustment to fit around that smart drop target that I have. I'll probably have to come back and mess with that one. That smart drop target I added a couple days ago. Two here. Yeah, so that smart drop target, I can't rotate this flipper assembly because I have a stand-up right here. This smart drop is part of my kind of like Denisi lock. So what I'll probably end up having to do is remove this target and put a post there, so that way I can swivel this flipper assembly. But I'll just keep those projected for now. So I got all 8 on that one. Go back up to here. So this is actually a diverter, not a flipper. So I'm just going to use a flipper assembly for it. Probably a better way to do that, but trying to somewhat use what's already available. Come on. Sit here and think for an hour. Alright. So that's the flippers. Next. So left orbit, I did that one. The launch diverter. This one here, I got that. Did that. And flippers. That one. Got that one. That one. That one. Alright, so all those flippers are good. The others are the bats. Yep, okay. So, I'll just hide the whole flipper category. Making progress. Do the magnets. And there are 5 that I gotta do. Oh, I never built a bracket for that one. Shoot. I'll just have to do that later. Well, I'll do the holes for the magnets now. And I'll just have to add holes for that other bracket later. One, 2. Three. And let's get the 5th one. Alright. I didn't get this one. Too many magnets. Is there such thing as too many magnets, though? Okay. That should be, by looking at it, all those. I gotta remember to build a bracket for that other little magnet. Mini magnet. Did I kind of build one already? That's that. I kind of did and I kind of didn't. It's built into another one. Okay. Well, I'll just have to build that other one. 2, let's go hide those. Need to make note of that little magnet bracket, which is the right orbit. Okay. Notated. Take care of the launcher assemblies. Which, these are a little bit more of a pain because they're not actually a circle. So let's get all the edges on all the mounting points. Is that all of them? Up here. One. All 4 holes on this guy. Good enough there. Then I should be able to hide my launchers. This file is so slow now. So much crap going on in here. Remember when I started working on this, this is my first time in Fusion 360, and I'm like, oh man, this software is really cool. It's fast, it does a lot of cool stuff. And now, it still does a lot of cool stuff, but it takes an hour to do anything. Okay. Targets will probably be the last thing I do. Let's do this one so I can hide this diverter. This diverter actually just uses an up-post assembly to articulate a diverter. Any other, like, diverters that I can... One back here. Alright, that's that diverter. What do I have? That one's a topside assembly. Sorting hat is also topside. So that should be all the diverters. So let's put all those back in and hide the group. Good stuff. Do the Vux. And this particular one, I'm gonna have to trim one of the wings on it and drill a new mounting hole. I'm not even gonna bother doing a pilot there. This one, I can do all 3. I'll just kind of grind the corners off there so it doesn't stick out too bad. one I can do all three. And this one I can do all three. Alright. So that is all the Vucks. No more Vucks to give. Submit that and hide the Vucks. Yeah, those two exist. Alright. Starting to look a little more clean, right? This 3-drop target bank. Actually, yeah, that should be good. I'll put those holes in place as well. I was unsure because I'm like, well, I need to make that a smart drop, but you can't really buy a 3-bank smart drop, can you? Or if you can, there probably isn't a CAD file for it. Alright, so there's that drop. See if we can get in it. This one. And I hope most of these CAD files are accurate with the hole placement. A lot of them I made myself, and those were based off of actual specs. But the question is, some of these other ones that I grabbed offline, how accurate are they? Like any of these smart drop targets, I grabbed that offline, so I would hope the whole position is correct, because that's like the biggest advantage of using these files is so you can correctly locate things. I wonder if there's variants from the manufacturers too, where the holes are. I would think it would be consistent, because it's probably a stamping or something. Okay, so there's all the drop targets. More drop targets I know of. Well, let's get those projections. Then I can hide my drop target group in a second when it calculates. There we go. Drop targets. So I got all those. We're good. Guess let's do the top bumpers. Those are through holes. I'll have to keep that in mind. Actually, it looks like I already have those cut. Don't I? 3, 1, 2, 3. Okay. Clear selection on the pops. I'll just do the pop switches for now. Then I should be able to hide my pops group. Okay. Hot bumper switches. Good. Let's finish that projection and hide my pop bumpers. What I'm really interested is finding out how much this actually costs to make. Slingshots. One of those should be through hole. And the other two are just screws. I guess I'll figure out the through hole thing later. There's one. Also, I got the through holes up front. Here. Yeah, there's one there. And one there. So I got the through holes up front. I just need to do the one in the back. Check that anymore. Alright. So there's the two slingshots there. And the one in the back here. Need to take care of that through hole. Okay. I should be able to hide the slingshot group. Yes, yes. Okay. I think we're into the custom mechs section. Do the custom mechs. Start in this corner and my way around. So this is the Hagrid's Hut mech. The rest of these holes for it. Alright. Hagrid's Hut. Check. The Whomping Willow. In theory, the structure of these mechs should be good enough. Going to be made from 16 gauge steel, stainless. So in theory, they should be strong enough and be mounted enough. But I don't know for sure. Okay, Whomping Willow's done. Take care of this one. This one is the inner left orbit forks that raise up out of the playfield, kind of like the chest forks in Pirates. So that's good there. Do the bracket for the captive ball lock thing. Holes. Right. And then, last but not least, mag rail. You can kind of see I already put like little locator holes in here, but I don't know if those are all the correct size. I did that early on. So what I'm gonna do is come back through here and drill those holes in the file just to make sure they're all the same. Because having them the same diameter not only ensures consistency, right? But also it makes it way easier when you're creating the toolpath to make these holes, because you can have it select the same diameter holes to perform the same operation. I want to try to make the toolpath part as easy on myself as I can. Okay, so that's one side. And we'll do this side. All the rest of these holes, and then I can hide my custom mech folder. That should leave us with targets and switches. Alright, all those. Any other mechs I'm missing? Got the rail, got those two, get those two. Good enough. Oh. Alrighty. Come on. Alright. Custom mechs folder. Whomping Willow, check. Gringotts, check. Horcrux, check. Hagrid's Hut, and Mag Rail. Alright, so those are all good. I had that group. I got all the diverters, so all of my mechs are good. So now let's enable those groups again. And hide the overall mech group. Sweet. Alright. Last one, targets and switches. Pin dividers and apron guide. Looks like I should have all those holes already. Yeah. Wondering what was overlapping those holes. Okay. Oh. Gotta do this one. So let's project that whole surface. Then what I'll do is I'll just custom the holes on here, so hide that. Make a construction line through the center. Change these to construction lines. And then 1.5 inches approximately, so I'll set the holes in 1/4 inch. And I'll be able to use the same sketch in a little bit to create the holes for the bracket, which should be, I forget how big, 0.156. So, 0.156. Oh, why does it take so long just to draw a stinking circle? .156. There it goes. Okay. Now all that is left are my switches and targets, which there are quite a few of those as well. Oh, same thing. Start working my way around. Get the rest of these holes projected. And I'll just kind of work my way around the perimeter of the playfield. Let's roll over here. This here is an opto bracket mount. These two targets. I don't think I've missed anything up that side yet. All right. Take care of all the targets in the dungeon cluster. Two I will need. These sense the Quidditch subway shot. And that's only because this subway is flush with the playfield. Everywhere else it sits lower, and those optos will be mounted to the brim of the subway. These ones I actually need pilot holes in the playfield for. Okay, those roll there. Working around. This one might need to flip the bracket on that. Let me come back to that one. And we'll get this little bracket. This is for the rollover switch. That's center ramp. Don't think I've missed anything up there. Top side, okay. Now, all these guys on my Horcrux pizza cluster thing. Right. On the front. And then one last one over here. Okay, that's all the way around. Let's get this opto bracket. That's for the long range opto that I use for the mag rail. Alright, there's those rollovers. And that should be all of the switches except for that one that I think I need to flip the bracket on. 'Cause there's a post right where that is. Alright. That's all those. Looks like all those have projected holes. Alright, looks like they all took. Alright, this guy. Inlane rollover, cherry switch. And then mounting bracket. Let's put the other bracket. I have a mirror image so I can kind of mount these either way. And with that, enable everything again. I just want to make sure that doesn't interfere with anything. Fix. Don't care about those upper playfields. Alright. Looks like that should work. Well, let's quickly project those last two holes. Okay. So the first thing that I want to take care of is I need a through hole on that upper sling. And I need it to be the same size as bottom slings. Let's go back through. Add all the stuff in. Spacers. Okay. So I need a hole that is 0.15 diameter. And that. Let's finish this sketch. And let's create my hole. Right here. And right there. Flat cut. 0.15. And distance, I have a parameter set up for playfield thickness. I'll just go all the way through. Alright, so that's that through hole. All my other ones I believe were already taken care of. Gotta go back and make sure that sketch is visible again. I'm gonna call this bottom side number 8 pilot holes, and I'm gonna call this pop hole direction. I need to make my pops a little bit smoother so it cuts out better. Back to the sketch. I'm going to project the holes for the pop bumpers. Like that. And I'm just going to connect those two side holes to the big hole. I'll draw a line there. And draw a line there. And set those as tangent to the projected holes. And trim those. This is going to give me a profile that I can just extrude through the playfield. And I've cut out that middle area. I'm wondering, I don't think it projected those two outer holes correctly. Oh, it takes forever. And I'll make that work. Do the same up here. And then tangent those lines. Alrighty. That's kind of one thing I need to check too. I have a pop bumper top assembly here. There's the center hole. I believe those two holes are for the light leads, I think. Maybe. if I turn around and look at, here we go. Here's the smart play. Headphone wire. Okay. Yeah, so there's holes in the top side that I need to account for. Okay. Those are fine on the side holes, but I need holes on the top side or the screw portion. I figure out how those, what the centering is on those, or spacing. Seven eighths. Seven eighths. We'll draw a line out 7/16 from there. That needs to be a top hole, top side hole. So, what have I been setting these to? 30 seconds? 3 second. That'll be my pilot hole on the top side. And hopefully that'll be positioned okay. Could be. It'll be fine. Yeah, it'll be fine. It should not take this long to draw a circle. Come on, Fusion. So, same thing down here. We're gonna do 7/16. And same thing. And create circles. Second. Alright, come on. There we go. That'll fix those. Now I can finish sketch. And let me take care of that stuff right now. So this profile and this profile all are going to extrude through. Just like that. It ain't perfect, but it's good enough. And then take care of those topside holes. So those two. And those two. And I'm going to start from the top surface in depth of 3/8. There we go. Alright. Then some of these holes that already exist, I want to check. Diameter is 0.078. .1875 or no. Okay. So I can create holes over top of those. They're bigger. Alright, so now the fun part. I gotta select all these holes, with the exception of... Oh, and then these down here I need to create kind of like a center hole. Alright, back to sketch. So any of these, like slot holes like this, I'm just going to draw a center line through the slot, and then I'll create a hole in the middle. Man, I'm so close to getting this cut out. I can taste it. Those holes are already good. I might go back and delete those. And what other slot holes do I have? Should be the switches for pop bumpers. Oh, let's see. I have one here. Pop bumpers. So much work. But I can't wait to get this actually physically flipping. That'll be the fun thing. I hope. Or it could be entirely painful and I'll just burn my barn down because I hate the world. Alright. Those are the slot switches. I'm going to delete the points that are through holes. Those two. Good. Look at this. Like, I'm just deleting sketch points. Why are we computing? Does not compute. This post hole is in the middle of a oh, that's right. I wasn't even going to do that one. I need to fill that one back in. This one, I can trim that T-nut. That's fine. I feel like there was somewhere else where I had a post hole that was overlapping something. Maybe not. Okay. So, I need holes on the center of each of these. They don't need to be perfect. But it just needs to give me something to grab onto. This is probably easier. I'll just do varying holes based on lot size. These don't have to be perfect either, because all I'm doing is I'm using them to grab points for my whole function. Not actually extruding this geometry. Alright, there's those four, and then the last one where my need to do that one. Center, edge. Here to edge. Same with these two up here. Edge. Edge. Is here. Center to edge and center to edge. There we go. Alright, now that sketch is finished. Now, how many objects are here? Pretty sure it gives me a count, maybe, maybe not. Oh, come on. That doesn't tell me anything. All that for nothing. Come on. That was just, I'm just hitting the escape key, that's all I hit. Like, is it really that hard to deselect? Apparently it is. Alright, I'm gonna save this in case it decides to get funky on me. In. So many notifications, way too many. And they just keep pouring in. The save takes a while. Come on. Alright. Saved. Now the whole function. Alright. Let's set the size of these. They are 3/32. They are 3/8 depth. Now I just gotta go through and select every one of these. Let's take care of the slots. So these are all my pilot holes for the number 8 screws. And then once I get all these modeled in here, in theory, I can start progressing to the toolpath. Alright. These. Get all my flipper holes and all these holes. So many holes. Okay, so far so good. Keep working up the left side here. Holes. And it's thinking again. Classic. There it goes. If I recall, the last time I was making holes, the function starts to kind of lag out the more you select. I'll take care of the... Well, let's just do these now. I'm gonna say I'll work my way around and then come back to the mag rail. The other thing I need to figure out is how I'm gonna do the lighting around the mag rail. Just because right now it's just got enough clearance for the magnet to travel back and forth, but I need to figure out how I'm gonna light it. I'll probably end up using strips, but I need to make room for those strips in my playfield. Right. Take care of the strap target bank. That's a target, I believe. That's a target. That's Sling. That's a drop target. Also a target. Mounting rail magnet. Fuck. Mounting rail magnet. Magnet. Come back over here. I don't know how. My dog just randomly started barking at nothing. So these got misaligned somehow, somewhere. But for now, good enough. I already took care of that through hole, so I should be able to just keep going around here. Which is not entirely sure what those. Oh, those were optos. This is a buck. Target. Another target. Drop target. Which drop target. There's that flipper. Flipper target. Magnet. Mounting rail thing. This is diverter thing. Vuck. That is a drop ramp coil. Okay. Don't see any bits of purple that I missed up top or on the left side, so let's continue. Ring guts mech. Captive ball mech. Targets around the captive ball area. It's really thinking now. How many holes? Up to 228. We'll make it. Do it all in one operation. That's the rest of those targets. Take care of this Vuck over here and this target here. Mag rail mount. Rest of these holes on the mag rail mount. This is very boring, I apologize. Like, oh, let's just sit here and watch somebody click a bunch of dots on the screen. How cool is that? This is some of the best content Twitch has ever seen. Sling. Inlane switches. The left launch diverter. It's good that I can just sit here and recite what all these holes are for. By good, I mean yes and no. It's terrible that I've been working with this so long that I know what every hole is. But it's also great to have that knowledge, because when it comes to assembly, shouldn't have to come back and reference the CAD too much. Is the subway sorting back thing. This is the rough. These are for the magnet. That should be everything. Just need to come back and fix this post, but I can do that later. 309 holes. Woof. 309 screws for the bottom. Top side is probably going to be nowhere near as much, but still quite a bit. Oh, there it is. Look at that. Sure is starting to look like a pinball playfield, isn't it? Let me fix this. That's two. Here's a nice fix I found for holes, like through holes, because there's no like surface for you to grab and extrude. Grab the go back to the solid tab. Click offset face. Click the inside face, and just like that, boom, hole is gone. All right, that should be it. That's an achievement. So, well, we've done this part. The next part is going to be creating the toolpaths. I didn't do optos down here yet. And I need to do the right orbit magnet bracket. But I can check some stuff off the list. Spade bolt holes. Most of the pilot holes. Okay. What drawing did this? Ramp indents. Back to this. Distance 2. Alright. And this is also... When did that go in? This one. That's a little more realistic to machine that out. Oh, and I forgot. Distance, 2 objects. There we go. Now we're getting better. Yeah, so that's playfield. Save it. Do I want to keep going? I feel like the toolpath thing is going to be another multi-hour stream. Maybe what I'll do is I'll take a break for like dinner, since I didn't eat lunch, and I'll figure that out. And then if you're still hanging around, I'll go back live and work on the toolpaths. Such a hard word to say. Toolpaths. The THS. Paths. Toolpaths. Man. Okay. What an achievement, though. I mean, holy cow. To get all the holes and everything in place and everything that needs to be cut out. Like, this is a huge milestone in this project. Because up to this point, it's been a lot of designing the mechanical function, which, that's been a huge feat. But I've gotten through all of that, and that finally got me to the point where I could start putting in the holes in the playfield. And now I should be able to start creating the toolpath to cut everything out. Oh, wow, wow. Ugh. Okay. Well, so if you're still here, let me see if anyone else is maybe streaming some pinball action. We'll throw a raid over. Pinball. Yeah, who we got? Let's go with... That's a lot to type out. Oh. Ipsy Pinball. Ulick Fair Strike Tournament. Raid. YPSI Pinball. Alright. Looks like it took. Cool. So thanks for hanging out. Appreciate it. Check back in later, and I'll probably be streaming again to do the toolpath creation. So, thanks. Appreciate it. Have a good day. Maybe see you later.